The Physics Behind the Northern Lights by Emily Schloff. I chose the Northern Lights for a few reasons. First, I would like to see them one day because they are so beautiful, and I'm fascinated that these light patterns can occur. I also did not know previously how they occurred, so I thought it would be fun to learn how they happened based off of what we learned in class. The northern lights are moving or dancing light patterns that happen from collisions between charged particles from the sun and the Earth's atmosphere. These lights can occur at both the north and south poles. They are called aurora borealis at the north pole and aurora australis at the south pole. These light patterns may appear in many forms. They also are seen in several colors, but green and purplish blue are the most common. The Earth has a magnetic field similar to a magnet. The geographical North Pole is actually the South Pole of a magnet. Since opposite ends of magnets attract, the north end of a compass will point towards the North Pole because it is the South Pole of a magnet. When these charged particles from the Sun come in contact with the Earth's magnetic field, they will flow from the South Pole to the North Pole because Earth works like an upside down magnet. Particles are still technically flowing from north to south like a magnet, they just don't appear like that to us. These particles are deflected by the magnetic field and will follow the path of the field towards the poles. The particles will collide with air molecules at the poles, since this is where the magnetic field is its weakest. To define what the Earth's magnetic field is, we can use Biot-Savart's law. This formula breaks down what the Earth's magnetic field is at a specific point. Taking the integral of this equation over dl would give you the total magnetic field of Earth. When the charged particles make contact with the magnetic field, these charged particles hit air molecules in the Earth's atmosphere. These collisions excite the air molecules, which means they gain energy from these collisions. This is due to electrons moving to higher energy levels in the air molecules. When the electrons move back down to lower energy levels in the electron cloud, they give off this energy that produces light. The northern lights can be many different colors. These color differences are due to the different air molecules that the charged particles collide with in the atmosphere. Green light is the most commonly seen color, which is from colliding with oxygen. Purple and blue are also quite common, which is from the particles colliding with nitrogen. Since the northern lights are caused by interactions in the magnetic field, people would not be able to alter the lights right now. Greenhouse gases would be the only way that humans could possibly affect them. These greenhouse gases would affect what color the northern lights would be due to the increased concentration levels of different molecules. Currently, there is no evidence that greenhouse gases have affected the lights right now.